Hi guys, Shouvik here. Welcome back to your YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have this problem: distribute candies among children too. So what they have given to us in the problem? So they have given two positive integers in and limit. The question is just for one line only, and we will definitely get a gist on the very first one. And we with these two positive integers like in and limit, return the total number of ways to distribute in candies among three children. So how many candies we have? We have total of n candies. That is the n they have given to us. So that candies we always have to divide between three children. The children's number is constant here. So we have to divide the candies among three children such that no child gets more than limit candies. So this is the limit factors they have introduced. So limit basically the upper value of candies a particular child can have at. The upper value of the candies that a particular child, a single child can have it. A single child not allowed to take more than limit candies. So that basically the limit stands for. So we have to return the total number of ways to distribute n candies. Yes, I think the problem is pretty understandable on very first go if you read it thoroughly. So on this example test case, you can see our n is 5 and our limit is 2, right? The n is 5 and the limit is 2. So output is 3. So there are three ways to distribute 5 candies such that two childs gets more than one candies. So these are like 1 2 2 you can do, 2 1 2 you can do, and 2 2 1s. So this all are the combinations that we have it. So that's the reason the answer is 3. Now if n is 3 and our limit is 3, if both the factor is 3, n is 3 and limit is 3, there are 10 ways to distribute 3 candies such that no child gets more than 3 candies. So what are those? So here you can see like there are total 10 ways. 0 0 3 is 1, 0 1 2 is 1, 0 2 1. Like this, there are total of 10 ways. I think you guys should get the problem statement on the very first go. So it is very simple. So they have given like total number of candies that we have to distribute, and the children number is always constant, that is of 3 children in all the cases, and there is a limit factors. Limit factors basically stands for a single child is not allowed to take more than limit candies. So that is the limit factors they have introduced. So now here you can see our constant is in the range of 10 raised to the power 6 and our limit is also in the same like 10 raised to the power 6. So we definitely have to think of kind of big of n square is not going to work. So we definitely have to think of kind of big of n or big of n log n kind of solutions for sure. So how actually big of n square should be looks like. So let's first define that. So what I am stating. So if they have allowed us to do a big of n square. If let's suppose n value is in the range of 1000 only. So we can do for first we can assign first in range. We can start it from assign to 0 to what is the boundary candies it can have. It should have limit candies, and in Python's the last boundary is exclusive, so we have to take plus 1, limit plus 1. So that is the first for loops iterations. Now my second, now I can run another nested for loop. My second in range same, like it should also run from 0 to limit, so that is of limit plus 1. Yes, agree guys? Now I can definitely add. Now my third contributions, how much third is going to get? My third is going to get n minus first. Tell me, n minus first minus second. N minus first minus seconds. And if I am able to tell, if I am able to see that my third, what is the conditions now? If my third is kind of like less than or equals to my limit, because first and second is already within the boundary of limit. If my third is also, so first, second, third is a valid combinations. So I can do answer plus here, and finally I can return. Finally, after this two for loop nested executions has over, I can return my answer. Yes, I should definitely able to do so. So that is of two for loops is a nestings for sure. This for loops is going to be big O of limit, it is iterating, and this for loops is also iterating big O of limit. So the time complexity on this case big O of limit squared. Yes, big O of limit squared. But the limit can grow as 10 raised to the power 6. So 10 raised to the power 6 into 10 raised to the power 6 is going to be 10 raised to the power 12, which is more than 10 raised to the power 8, and you will definitely get a for sure shot TLE. So now we have to definitely think of kind of optimal solutions. Now actually our intuitions building part is going to be start from this part. So the first things. Let's suppose there are conditions, right? Yes, there are conditions. So how actually we have to think of kind of solutions, like we have to think of kind of intuitions here. What actually the facts? So there are two numbers altogether they have given us. One is n and another one is limit. So there are cases, right? There are cases. If let's suppose what is the total number of n they have given to us, if it is less than or equals to my limit, right? So already the candies that we have at is already the total number of candies is altogether smaller than the limit. So on that case, is there is a conditions, can there is a conditions ever happen that any of them is going to take in any permutations or any combinations I can do, where some of them like either first, either second or either third is going to take more than limit candies. It is never possible, no, because our total number of candies is altogether smaller than my limit. Yes. Then on that case, let's see what can be a case. So we will again try to write the brute. So my first is going to iterate in the range of 0 to now on this case in yes, agree guys, because our limit is higher, my limit is higher. Yes, so it is going to be iterate from 0 to n. So that many, so I can assign from 0 to all the candies to the first guy, So what is the rest candy I have at? After like assigning first to any value? So can I write it n minus first, because I have assigned any number from 0 to n with the for loop of first in the range of 0 to n. I have assigned some first value to the first guys, to the first child. And how many then rest candies we have at? I have persist n minus first candies to assign to second and third child, Now let's define a table. So that is of second and that is of third child, right? So let's suppose I can assign 0 candies to second, and what are the rest candies? This is nothing but rest. So I can assign all the rest candies to the third guy, or I can assign one candies to second and rest minus 1 candies to third, or I can assign 2 candies to second, rest minus 2 candies to third. Agreeing? I can assign 3 candies to second, I can assign rest minus 3 candies to third. Like this. This is going to be monotonic increasing. So one time I am going to assign all the rest candies to second, and the last, that is of my third one, is going to get 0 candies. That is just reverse, because we have started from 0 to rest and we have landed to rest to 0. So how many rows, how many ways we have total identified here? How many rows here? From 0 to rest. How many? This is nothing but rest plus 1. This is nothing but rest plus 1. So that means now if we can go to now example test case now. So we will first try to define where n is less than equals to limit. So that is this case. That is example case of 2. So there we have it. Oh shit, man, it's stuck. Yeah, it should work. It should not give me. Please work. It will. Yes, it's working. But not. So now I can try to define. So yes, man, you are correct. So our first is going to iterate. So my n is 3, and my limit is 3. So if my n is smaller than my limit, so I don't have to altogether care of my limit. I can get rid of. Only I can play with n. So I can try. When I am assigning 0 candies to the first, then on that case, what is my rest value? N minus first, that is 3 minus first, that is 3. So my rest is coming out as 3. So if I can write it in tabular, so this is my first value, this is my rest value, and this is my ways. So when I am assigning 0 candies to first, my n, we know my n is 3. So 3 minus 3 is, my rest is coming as 3. N minus first. So first is 0. So 3 minus 0 is 3. So ways is always. We have already defined from 0 to rest. So that is of plus 1. That is of 4. When I have at 1, my rest is bound to be coming as 2. My ways is 3. When my first is 2, my rest is going to be 1, and this is going to be 2. Agreeing guys? I'm just following the patterns. Yes, I can do. When my rest first is 3, so my first can grow from 0 to n. Now that is the ultimate. So my rest, we don't have to assign any candies to second. So what is the ways then? Rest plus 1. So you are getting, right, y raised plus 1, because our first, second, third can grow from 0 to raised. So that means we have start 0 candies to second, and then what is the raised value? Raised is also 0. So 0 0 is a valid. Then I can't go. So that is of 1 way. So that is of when my raised is 0. So we have raised plus 1 way. So my raised is 1. So now what we need? My first when my first is 0, I have total 4 ways. When my first is 1, I have total 3 ways. When my first is 2, I have total 2 ways. When my first is 3, I have total 1 way. So it is nothing but, what is my then answer? It's nothing but the summation of those is summation of those is summation of those. I mean, guys, it is coming to be 10 only. So can I define a formula? Is it a monotonic APC? Is it a monotonic increasing or a AP series? It is nothing but 1 plus 2 plus 3 plus 4 plus dot of how far it is going. If my n, so my n is 3, so it is going to n plus 1. It is going to n plus 1. Yes, because it has started from 0. So from 0 it is growing from 0 to n. So how many then rows? N plus 1 rows. So it is grow from 1 2 3 4 like plus n plus 1 it will grow. So what is the summation then? If it is n, then my formula is n into n plus 1 by 2. If it is n, if the series is go to n, 1 plus 2 plus 3 plus 4 n, then my formula is n into n plus 1 by 2. Yes, and now my n is altogether n plus 1. So in place of n I can put n plus 1. So this is of n plus 1, and my n plus 1 is going to become n plus 2, right, by 2. So this is the formula. So I define the formula when my n is smaller than equals to my limit. Yes, agreeing guys, agree. So my if n is smaller than my limit, I can directly use the formula and to compute my answer. Yes, now go to the code once to see this particular if block. That is very simple. So I am checking at if my n is smaller than limit, then I am returning n plus 1 into n plus 2 divided by 2 that we just saw in the one note. So I can directly use the formula. But if it is not, now define that particular block. So that is the complex one. So now I have defined. So now when this for loops is coming to the outside boundary, my n, it's going to be upward, downward. Yes. So my n is bound to be more than my limit. My n is more than my limit. So there can be a chance that whatever the assignment we are doing, because on the first case it is very simple, it is straightforward, no, because n is altogether smaller than limit. So there is always, so in naked eye, you guys able to see there is bound to be a formula we will definitely define, because there is a, because we can select any of them in any order, and we should be able to within the boundary only, because our n is altogether smaller than the limit. But here it is not. This case is complex. So when my n is greater than my limit, so on that case, I definitely need to define my first. So I will do the naive way. That is we have done that we have done for the group. So my first, I will iterate my first in range. Now I know my limit is higher, my n is higher. So what is the opportunity of assigning first? I know each of everyone's is going to take only limit candies. So I will take from 0 to limit. So as limit is, Python is exclusive of the right boundary, so we have to iterate to limit plus 1. Yes, we can do. So my first is in place. So that is the combinations of first. And before of that, you can define your answer to be 0. That is, I think you guys are already doing. And on now, what is the rest 2? Now previously on the brute, you remembered I have wrote another for loop from here for second in range, again from limit plus 1. That is going to be take off big of n square. But we are not allowed to do so. Because that is going to be take off quadratic complexity. We definitely have to think to compute our answer in kind of, here I have opportunity, you can compute in big of 1 or log n. At max to max I will assign to log n only, not more than that. So my rest, that is rest 2, I can write it on more generic, like rest 2 is nothing but total candies I have n. So I have assigned first candies to first guys, so I have pending with n minus first. So the rest 2 is going to get this many candies it's going to take, rest 2 candies it is going to take. Agreeing guys? Agree? Definitely you guys bound to agree on this. So now we have a trouble, what is the, now I want to define what is the boundary I can assign of second and third. For this first, I know first is within the limit. Now in second and third, or more specifically in second, because third is very simple, third is nothing but raised to minus second. So on second, I definitely need a boundary where my where in which I can assign my second, so it is critical, you guys. If you are not able to like feel that pain, no, so let's put me to give you that pain, then you will definitely get it. So my rest 2, if let's suppose my first is taking 0 candies, then my rest 2 have to take, let's suppose I have total of 3 candies, and my limit is, let's suppose my limit is 1, and that is every child is allowed to take 1 candies only. So I have total of 3 candies to distribute to 2 children, and such that none of the children is going to get more than 1 candies. Are you guys able to see a pain? So there is a lower boundary for sure. And what is this? So if I am going to assign 0 candies to the second one, if I am going to assign 0 candies to the second one, then the third is going to take all 3 candies. It will not able to take it. If I am going to assign 1 candies to it, then second have to take 2 candies, and it is also not able to a valid configurations. Then if I am going to assign 2 candies, it is altogether not possible, because 2 is more than my limit. So there is no configurations altogether possible. But let's consider my limit is, they have increased to 2, or I can take this example test case what they have given. My n is 5 and my limit is n is 5 and my limit is 2, right? N is 5, my limit is 2. Shit, yeah, this one node is crying actually. This is working very slow. Full screen, not responding. Very good. Chat, it's not responding. Okay. Is it allowed? Yes, it's working again. So here what they have given to us, my n as 5 and my limit is n as 5 and my limit is 2, so I am in kind of trouble now. So the limit is 2 all the cases. So what I can do, if I can try to rewrite it on this particular test case, I can assign 0 to my first guy, and what is the second it can have at, so my second, let's suppose I'm going to assign on rest 2, I have on rest 2 I have all the 5. So if I am a little bit like unconscious here, if I am going to assign 0 to, what is the boundary we have it? We have the boundary of 0 to 2, right? For the second, what is the boundary? The boundary is again same, 0 to 2. If I am a little bit unconscious to assign 0 candies to the second one, then third is like, say, man, you make me like out of control, because I have to take all the 5 and I am breaching the limit, and if your configurations is invalid. So okay. So now again for 0 only. If I am saying okay. You can take 1 candies. Second, can you help me with 1 candies at least? Second candy says yes, obviously, because I have the limit of 0 to 2. I can take 1 candies. So then on that case, okay man, you still not like think about myself, and I have to take all the 4. Your combinations is again invalid. Okay, I see. So I am going to then say, okay, then can you take 2 candies? Can you take 2 candies? Okay, I can take. Then on that case, I have to take 3 candies. Oh no, it's still not possible. If I have to take 3 candies, then also it's not possible. So if you are going to assign 0 candies to first, then there is no altogether configurations exist. There is altogether no configuration exists by which we are able to do the job. So now let's try to assign 1 candies to the first guy. So first can grow from 0 to 2, right? Then on that case, I am saying, hey, second, can you take 0? Yeah, I am good. I am within the bound limit only. Then on that case, oh shit, man, you have assigned, now you have to assign all the 4 candies to me. Invalid. Now, for one only. Hey, can you take 1 candies? Okay, second is stating, yes, I can. Now, on that case, I have to take all the 3 candies. It is also invalid. Okay. Now here, okay, first is stating, okay, second, can you take 2 candies, man? Otherwise, I am going to assign rest all the candies to the third, and third is out of limit. So can you take two candies. Okay, second is saying, yeah, I am still within the boundary. I am hitting the boundary, but within the boundary only. Hitting within the boundary. So on that case, okay, now you give me the first relief when you have assigned two candies, to the second, and my third limit is again within the boundary. Yes, that is the first point of validations. So for first also, you definitely have a boundary. Within the, so some of the first. So from 0 to limit you are iterating, no? So from 0 to limit you are iterating. So for some limit, so you definitely need to minimum assign that many candies to first one, so that second and third is altogether start its validation, start to valid. Because on 0 we saw that all the combinations of first 0 candies assigning to first guys, there is no combinations altogether valid. And for second also, there is a certain threshold. That is the 2. After which it start validating. Yes. If you assign more candies to me, then I am altogether going to be invalid. So for 3 is not altogether in answer. So second has a threshold of 0 to limit, and there is a particular point. There is a particular threshold point. In which for any first, if you assign that threshold number of candies to second, post that if you assigned any candies to third, it is valid. So for second there is a threshold point. For third it is computable, because first we have defined that second is lying on the threshold, and for rest we have the combinations, right? So for here we definitely, for second there is a definitely have a threshold in from 0 to limit. On this left side, if you are assigning a less, if you are assigning from 2 to 1 less, no, then it is invalid. So at least 2 to any of within your limit you can assign. From 2 to any of its limit you can assign, and this segment is valid and this segment is invalid. So there is obviously a monotonic sequence exists. So this second sequence, that is of this, can I say it is a monotonic sequence? It is a monotonic sequence. That you have to put. And when you have found a monotonic sequence, can I do a binary search here? Yes, definitely I can put a binary search here. So for first, I will define my race 2 that we are doing, and so that we are doing. Where it is gone, man. So my race 2 is in my hand. What is the binary search limit? My left and right should be my left, that is the second. What is the valid values of second? So it is in the range of 0 to limit. That is the boundary of my second. And there is a threshold point. Or I can write it as a second lower because it is a lower boundary, right? It is a lower boundary. Second lower, 2b is 0 to all of its left are invalid. And from this to all of its right, are valid. And so I can write so I can do a binary search. While left less than equals to my right, yes, my mid is going to be how I can compute L plus R by 2. Yes, right shift by 1, that we are following for very first videos. If I will make a calls to my helper, it is going to compute with this mid value. It is going to say me if it is valid, then I am looking for what is the first threshold, that is the second lower, what is the lower boundary. So I have to move my right to be mid minus 1. So till this it is valid. What is the boundary you are lying? It is valid. So you have to search, you have to shrink your searching space to right equals to mid minus 1, because maybe your threshold is lying maybe on lesser side, because we have to find what is the first points where it is start validating, and your second lower is going to nothing but tell me guys this mid, because this is a valid threshold. And else very straightforward binary search, your left should be going to be mid plus 1. Yes, agree definitely. Can you guys tell me what is my upper boundary? Second upper, what is my upper boundary? My upper boundary can be min of what is the limit of second? It is nothing but it is going to be at limit only. And how many candies we altogether have had to in my hand to assign to be second? It is of rest 2. Yes. Agreeing guys. Yes. So now so I have a second upper boundary and second's lower boundary. So if both are in kind of this second of lower less than equals to my second of upper. So let's suppose second is stating from 1 and my upper is stating 2. So from 1 to 2 you can toggle me. So how many toggling you are allowing? So how many toggle you are allowing? 1, for 1 you can select any of third it is going to be valid. For 2 it is going to be any of third it is going to be valid. So how many? So it is nothing but 2 minus 1. What is the gap? What is 2 minus 1 is 1. So 2 minus 1 plus 1, right? I think you guys are getting. So for 1 also we have a valid, for 2 also we have a valid. So it is nothing but upper minus lower plus 1, because 2 minus 1 is 1 and plus 1 is nothing but to consider both. So I can directly add to my answer plus equals to second of upper minus second of lower plus 1. Yes, and finally I can return my answer. Yes, I can definitely do it. I can definitely do these things, and it is going to give you an AC. Now only one part pending, that is of our helper functions. So what we are doing, so we definitely need, if this current configuration is altogether valid, so I have to pass this mid, that is the second. This many candies I am going to assign the second, and how many total candies of second and third we have it. So that is nothing but I will pass my rest 2. So that many candies we have it. Now my helper, if I can write it here itself, helper is very straightforward functions. So my helper, def of helper, it is going to take my second and rest 2. It is going to take 2 parameter. Then my third, tell me guys, third is nothing but my rest 2 minus second. So that many candies my third is going to get, because rest 2 is the total candies that second and third it is going to assign, and I have assigned second number of candies to second. So third is going to take off third number of candies, and if my third is greater than my limit, so that means these configurations is not valid, man. So then return a false. You have to assign more candies to your second, otherwise third is going to take more than limit, or else I can return a true. Yes, it's as straightforward as that. So now I can quickly discuss the overall code iterations to you guys. So exact same things I have done. Answers to be 0. My first can go to in the range of 0 to limit plus 1. Agreeing? Yes, definitely it can go. And my rest 2 is nothing but n minus first. And I have start with my n, my L, R, second lower, L is 0. R is my rest 2. And my second lower is 0. Yes. Agree. And now I am writing a simple binary searcher, while my left less than equals to right, my mid is this, and I am calling my helper function. Helper is very straightforward. I am passing second and rest 2. So what is the third then? Rest 2 minus second, and if my third is more than my limit, so increase your left, increase your second, because with this second third is going to hit, your combinations is altogether invalid, because third is breaching the limit, return false, and if it is returning false, then we are increasing our left to be mid plus 1, then we are searching for assigning more candies to second, and if it is true, then I am assigning second lower to be mid, and my right is nothing but mid minus 1, and my second upper is the minimum of what is the it can grow at max of limit, and what is the altogether it is holding. Altogether how many candies altogether we have it to assigning second and third. It is of rest 2. So I have to take that is the boundary of second upper can have it. And if my second lower is less than my second upper, I am increasing my answer to be second upper minus second lower plus 1. Yes, and finally I am returning the answer. Yes guys, I know this problem is little bit tricky to understand this. Finding the threshold of the second, here we can incorporate a binary search. It is kind of a tricky, and I have tried my best to explain to you guys. And now we can quickly discuss the time complexity. So the time complexity for this particular submissions is bound to be, this is big of 1, but for this, let's suppose we are considering the worst case where my n is all the cases is more than my limit. It is going to iterate for all the limit for sure. That is of 10 raised to the power 6. That is of 10 raised. So big of n, we are going to take an hit, and this for loops is iterating of raised to, and it can grow as big of 10 raised to the power 6 only, 10 raised to the power 6 only, but here we are doing binary search, so it is of big of n log n, yes. And my space complexity, do you guys see we are using any space altogether? Are we using any space? I don't think so. So on space complexity, it is of all our variables, right? All our variables only. Yes, man, all our variables. So on space we are very good. It is using big of 1 constant space, and it is within the boundary for sure of 10 raised to the power 8. And I am not going to say it is the most optimal solutions, because I have read some of the articles where people have able to submit in big of 1 also. So that is definitely a like most optimized versions of this by a very tough mathematics they have incorporated to do that. But I feel so a binary search of identifying the second results is more intuitive and more easy to implement, and also setting perfectly to the problems constant also, because our constant is as big as 10 raised to the power 6. So it is going to give you a perfect easy for sure. So that's the reasons I have opting for this binary search on answer, and it is indeed and going to be unacceptable. So, and if you guys are able to understand till this point, I have tried my best to explain to you. So please do subscribe to the channel. Please share the videos to your friend circle who are also preparing for top product based company and brushing up their DSS skills, and please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible, guys. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.